Good afternoon. How are you doing? And welcome to Math and Engineering Helpdesk. This is Jeff. Today I'm going to show you how to make scatter plots in Google Sheets. So I have a spreadsheet. This is made in Google Sheets just with some sample data, including some personal statistics about 6 made-up people who all happen to be in alphabetical by first name order. We're just going to use these 4 data sets of 6 people to make some scatter plots. So what we'll do first is we're going to select 2 columns of data. So I'll select these 2 columns next to each other just by clicking and dragging. And I'll just notice I'm selecting just the data because I want the scatter plot to accurately reflect an x and y coordinate pair on the plot. So we'll select that data. And what I'm going to do next is I'm going to insert a chart. There's 2 ways in Google Sheets to insert a chart. One of them is you can go to the insert and then select chart, or you can, select my data. You also can select this insert chart button on the toolbar, which as long as you haven't modified it. So now when you open up and create a chart, you're going to, of course, get a chart that's not what you want. You want a scatter plot, you don't want a column chart. And when you do the insert chart, it'll kind of default to that, or what it thinks is the best. So instead, we want this scatter chart. Scatter plot is called scatter chart in Google Sheets. And that will produce the plot that we're looking for. Now, the default is the column that's on the most left is going to be your x-axis, and the column on the that's the second column next to that is the y-axis. If you want the other way, you can do so, okay? But switching rows and columns here kind of makes for a slightly different change in plots, and I kind of like using this as our setup height, arm span, and I can always reorder things in the spreadsheet if needed. So we have our plot made. Now, things we want to do, we want to add some labels and titles. So we go to chart axis and titles, and that's under the customize section of Google Sheets. We go to chart and axis titles, and we're going to do titles. In this case, it's height versus arm span. And then we also can select a horizontal axis title, which in this case is height in inches. And our vertical axis title is arm span, also in inches. Okay, so those labels will now be on the chart, make it a little more informative. We also could change the text, change the font size, and all that jazz. We'll just kind of stick to just labels for now. Now, the next things that we're going to want to also do is the series. Now, we have the option in series to change the color of the plot of the points. Maybe blue's not your fort. Maybe some green would be cool. And we can also add some formats to that data point. Like we can also instead, we can say, hey, let's label those points as well. We don't need to do that in this case, but if we want to do that, we certainly can do that. We also can turn on data labels. It would just show us the x-axis value to kind of corresponds with the y value here, but we, again, kind of don't do that. You also notice that right now this data is kind of scrunched up a little bit. We're going to fix that in just a little bit. What we do want to turn on also is the trend line. When you turn the trend line on, you get a series of options. You can opt for other fits of data. Most of the items that we're going to be looking for would be linear. In the class that we're doing, we're only working with linear equations right now. But in future Algebra 1, Algebra 2 classes, you may also find polynomial, exponential, powers, or logarithmics as options as well. But we're going to do linear in this case. We also want to turn on the equation. The equation is useful for predictions and extrapolations and interpolations. In this case, the equation we get for the height and arm span is 0.631x plus 23.9. The slope that you get here is basically the ratio of your y-axis over your x-axis. So 0.631 means 0.631 inches of arm span per inch of height. All right, so that's kind of the trend that you would observe based on the sample made-up data that I've used here. We also have the option here to show R squared. Now, R squared is a measure of correlation. It's also called the correlation coefficient. Well, R is the correlation coefficient. The R squared is just basically the square of that R value. The R value can be between -1 and +1. If it's negative, that would indicate that the correlation is negative, and if it was positive, it would indicate the correlation is positive. You can determine positive or negative correlation based on also the slope of your trend line. However, I would caution that if your R value is sufficiently low or if your points are all over the place, it's probably not a good idea to indicate a positive or negative correlation. You want to kind of have it definitively. Also, additionally, this, as mentioned already, this graph is kind of scrunched up vertically. So we notice how we have most of our points, our y values are between 60 and 68 in our x and y axis here. So our y axis is 60 to 68. we don't really need all of this below here. So we're going to change this graph so that the vertical axis has a minimum and a maximum value. So I'll choose here 55 for the minimum and 70 for the maximum. That way, our graph, see now our graph is a little cleaner. We have a better idea of the data that we're looking at, and do notice that our x and y axes labels do reflect equal intervals and starting points. So allowing that to happen here. Also, this is an option here, allowing the bounds to hide data. This is if one of the values ends up being outside 55 or 70, this would not change the minimum maximum values that you set in here. However, unchecking this allows, well, I take that back. Unchecking this would kind of scrunch it up together and then would hide the information that you have outlined from minimum and maximum. We obviously don't want that. So allowing bounds to hide data is something that you want to keep checked. Okay, so scale factor, if we want to change anything about that, we can. We don't have to do that. And also use number format from the data, which is just numbers. Okay, so that right there is pretty much the scatter plot information that you would need. There are further customizations that you can experiment with. I will just save that for now, because most of the time when students need to make scatter charts, they need things like the trend line equation, the r squared or r value, which, by the way, you can find the original r value by doing the square root of this number. So since 0.3 is pretty close to 0.3, the square root of 0.3 would be, I believe, in the top of my head, I want to say it's going to be 0.5 something, 0.5, 0.52, 0.53, something like that. So the r value there of 0.53 is a weaker correlation. We would like to see r values that are greater than 0.7 to indicate a stronger correlation. So the higher this value is, that just means the closer that these data points are to this trend line, and also the better of a predictor of values that this trend line equation would provide. So here we have kind of a mid-level correlation based on this r squared value. Okay, so that's how you make a scatter plot here. We're going to make another one, but I also want to show you here how you can select data that is outside or not next to each other. For example, what if I wanted to make a scatter plot of arm span, arm span and the number of hours of sleep, which are two things that probably don't have anything to do with each other. Again, even in my made-up scenario. Notice how I'm able to select two columns here, and I can do that by holding down the control button, the CTRL button on my computer, while I click and drag other areas. So I also can kind of deselect items by holding down control and clicking. It'll keep my other selections active. So when I want to make a scatter plot of this data, notice I have two non-adjacent columns. It will still use arm span on the left and hours of sleep on the Y. And then if I go to make a scatter chart, it'll do the same thing. See how there's our scatter chart, there's our x-axis and y-axis. And this is an instance where maybe we want to keep the 0 in because the range of the y-axis is not that large, our distance from 0. And we'll kind of do the same things. Let me turn on the trend line and the equation and r squared value. And we kind of have, as you can see here, an r squared value of 0.3. Okay, it's not that much better than this particular correlation. So we would say this is sort of a mid-level correlation. This is also, this is not a very large sample size. So, you know, if you really would like to say, yeah, your hours of sleep is directly influenced by your arm span, the longer your arms are, the less sleep you get. Hey, maybe that is true, but maybe with only 6 people and 6 made-up people at that, probably not a conclusion we want to reach right away. So anyway, there is the information that you need right there to make some scatter plots in Google Sheets. Hopefully this video helped you. If it did, give it a like, give us a subscription. We're almost to 600 subscribers, which is mind-blowing to me. I'm glad to have provided such helpful content for math and engineering here on this channel. As always, if you have suggestions or requests, please provide them to me. I have listened to them in the past, and I have made videos by request. Hope you have a wonderful rest of your day, and don't forget to be awesome.